Alright, today's lesson is lesson number 70. We're going to be talking about factoring by grouping. So we've talked about a lot of other methods so far, like just finding the GCF or using Xbox or looking for patterns like difference of squares. So we've used all of those methods for factoring, and now this is another tool for us to be able to factor. Okay, so here are the steps. First, you're going to identify any coefficients with a common GCF and variable. Again, it says any coefficients here, so it doesn't necessarily have to be in every coefficient like we've seen in the past methods. Okay, then you're going to rewrite the expression with those terms adjacent. Adjacent is a word in math that just means next to. Okay, it's a word that will come up, especially in geometry. We use it a lot. So adjacent is just like saying next to. So you're going to rewrite the expression with those terms next to one another and then factor out the common factor and continue to factor as much as possible. Okay, so here's a couple examples. For number 1, first I'm going to start by factoring each of these coefficients to look for common factors. So I have 14 is 7 times 2, 12 is 6 times 2, and then 7 and 6 are both both coefficients in my expression as well. So I'm going to just look at those as 7 times 1 and 6 times 1 because I see that gives me matching factors here. So the first and third term both have 7 in common, and the second and last term both have 6 in common. So I'm going to start by grouping the terms with the 7 in common together. I see they also have a variable in common. They both have at least one k, so I'm going to be able to factor out a k as well when I get to that step. First, I'm just going to rewrite it though. So I'll rewrite here the ones that have a 7k in common first, and then the two terms that have a 6 in common. I'll write those afterwards. Okay, now I'm going to go ahead and factor it out. So in these first terms, like I said, I have a 7k. When I factor that out, I get 2k squared. So remember, if I do 14k cubed divided by 7k, that gives me this 2k squared. 7k then divided by 7k is just positive 1. And that's all that I can factor the 7k out of. So now moving on to my second two terms, I'm going to factor out the common term there, which was a positive 6. When I do that, I'm left with 2k squared plus 1. And hey, look at that. In parentheses, those are the same thing. So now I'm thinking I can actually factor this further because really I have another common factor in these terms. Okay, so I think of this as 7 times k times something plus 6 times that same thing. So since that red box part, right, the part that's in parentheses, is exactly the same and it's in both terms, I can factor it out. Just like I did in this step with the 7k, how I factored 7k out of the first two terms, now I'm going to factor out 2k plus 1 from both of these terms. So I take what's in the rectangle, I'm going to factor it out here and then write what's left. So 2k squared plus 1 goes in here. Then what's left when I factor that out here, I have a 7k. And for the second term, I just have a positive 6 left. Okay, so I'll just rewrite my answer then without the red box. So I have 2k, this should be squared actually, 2k squared plus 1 times 7k plus 6. Okay? Okay, so that's my final answer for number 1. Okay, I'm going to move on to number 2. I'm going to start in a similar way. So I start by factoring these. I'm looking for common factors. I know that 24, that's like 3 times 8, so maybe I'll start there. 21 is 3 times 7. 64 is 8 times 8, and 56 is 7 times 8. So I see I have a lot of 8s and a couple 7s. So I'm going to start by grouping the 7s together because I have 2 of those. And then I'm going to group 2 of the 8s together, so the 2 terms that I have left would be these 2. They have that 8 in common. Okay, I'm going to rewrite this with the terms with an 8 first. I notice they also have an x in common, so I'll keep that in mind as I move forward. First, I'm just going to rewrite this. So I have 24x cubed minus 64x plus 21x squared minus 56. In the first two terms, I have that 8 in common and the x, remember I said? So I have 8x that I can factor out of those two. My parentheses. When I factor out the 8x from 24x cubed, I'm left with 3x squared. When I factor out the 8x from negative 64x, I'm left with negative 8. The x's cancel out, remember? Okay, in the next two terms, I'm going to factor out a positive 7. And when I factor out 7 from 21x squared, I'm left with 3x squared. When I factor out 7 from negative 56, I'm left with negative 8. Okay, and again, I see that this term is actually in common between both terms in my my expression here, so I can factor that out. Okay, so I'm going to pull that out in front of the expression. So since that's in both terms, I can factor it out. So that goes here. I have 3x squared minus 8. I'm left with, when I factor this out of the first term, I'm left with 8x. When I factor it out of the second term, I'm left with a positive 7. Okay, so that would be my answer. I'll just rewrite for neatness. I have 3x squared minus 8 times 8x plus 7, and that is the final answer. Again, I should probably look to make sure that I can't factor this any further. For example, if I had a difference of squares, if it was maybe just x squared minus 9 as the first term, I could factor that as x plus 3 and x minus 3. So that's something that I should keep in mind. All right, but for now we'll move on. So pause the video here and write these in your notes if you weren't in class today. And then I'll move on to 3 and 4. Okay, so number 3, factoring number 3, this is what I get. Okay, I see I have 7 and 4, 7s and 4s in common. So I rewrite with the 7s first. Or actually I wrote, with the terms with a 4 in it first, so 12x cubed plus 4x. And then the other two terms that have the 7 in common after, so 21x squared plus 7. Now I'm going to factor out that GCF, which is 4x for the first set and 7 for the second pair of terms. When I factor out the 4x from 12x cubed, I get 3x squared. 4x divided by 4x just gives me a positive 1. Factoring out the 7 from 21x squared, I get 3x squared. And factoring out the 7 from 7, I just get plus 1. Okay, again, these terms are in common, so I can rewrite this in front. I'm left with 4x plus 7. Okay, and that's my answer. So moving on now to number 4. I chose to factor this way because I noticed that I have some terms with 5 as a factor, and then I have the 3 and the 7. So I want to kind of use those numbers so I can find common factors. I know that so here I have 5 in a couple of terms, I've got 3 in a couple, and 7. So I'll just kind of start with the biggest number that I see in two places. So I see 7 here and here, so I'll group those together. In the two that are left, I have 3's in common. Okay, you want to make sure you touch each term separately. Okay, you can't double dip into, like, say, the 35. So I wouldn't want to do the 5's because I already accounted for that term with the 7's. Okay, so rewriting this with the 7's and the 3's grouped together, I have this. So the 3's are grouped together first and then the 7's. In the 3's, I also notice I have p cubed and p as my variables, which means they have a p in common, so I could factor out 3p here. When I do that, I get 5p squared plus 1. And in the second set, 35p squared and 7 have a 7 in common. 35p squared divided by 7 gives me 5p squared. And then 7 divided by 7 is just 1. So that what's in the parentheses is common to both terms, so I can factor that out. 5p squared plus 1. And I'm left with 3p plus 7. I could also write that like this. It's just, I could write the terms in either order, remember, just like for the other factoring methods, as long as you have the two sets in parentheses being multiplied to each other, it's the same answer, either way here, okay? All right, and the last one we did in class was number 5, so I'll show you what we did for that. I sorted it this way. The first two have 6m squared in common, so I was able to factor that out, the m squared. And then in the second two, I have a 7, but I also noticed that they're both negative. So I went ahead and factored out the negative 7, and that left me with 5m plus 1. If I hadn't factored out the negative, I would have negative 5m minus 1, and I might not see that I can continue factoring. So this way I see that those are both the same. They both have 5m plus 1, so I can factor that out. And I'm left with 6m squared minus 7. Okay, and that's my final answer there. Okay, so after these 5 problems, we talked about some closing questions. As far as fitting into real life, besides uses for factoring that could be seen maybe in like engineering fields, we talked about how the general idea of being able to sort, being able to look at something and pull out important information and look for similarities and sort things according to their similarities or what they have in common is a skill that comes in handy a lot of times. So that general idea, the logical thinking behind this is something that we would use in real life. And then here are some practice problems if you want to give these a try to see how well you understand it. Before, if you're getting stuck on the homework, maybe try a couple of these, see what you get, and compare it to the answers on the next slide. So pause here if you're going to work on these, and I'm going to click to the answers. Okay, so this is what you should get on these problems. All right, that's it for today's lesson. Thank you, and we'll see you tomorrow.